Hello. First of all, I would like to thank you for the presence of our conference on research, industry, administration in maritime sector. This conference is part of the activities within the project Marine Training for Seagoing Courses that you can see over there, the pull-up. This is a project of EA grants funding. It's about 2 million euros of funding for acquisition of new simulators and networking with 2 Norwegian universities, NTNU and USN. So this conference is very important for us, and I would like to thank all the speakers that accept to participate in the conference. And the intention is to demonstrate the potentials and the capacities of the Portuguese maritime cluster, considering that we have here a delegation of the 2 Norwegian universities. So we are going to start the first panel dedicated to maritime research and industry. And the first speaker is Professor Sérgio Ribeiro Silva. Is an associate professor of CEMTEC, Institute Superior Técnico from University of Lisbon, and he will talk about research projects at CEMTEC IST. Since he's out of the country, he will participate by video conference. So let me introduce Professor Sérgio Silva. Thanks for the presence. So please share with us your interesting topics that we are going to discuss. Thank you very much.
Hello, ladies and gentlemen. I'm speaking from Hamburg in Germany. I'm attending now OMIE conference, and I have met many Norwegian colleagues here. Actually, SINTEF, one of the research institutes in Norway, is the major sponsor of this conference. And first of all, I would like to thank you, Professor Luis Batista, for this opportunity to come to this conference and present our research projects at CEMTEC and MARTEC. I believe some clarification is required. Actually, I have been active member of CEMTEC for over 20 years. I wrote 50 papers in this research unit, and more recently, I moved from CEMTEC to MARTEC. Actually, both these research units belong to IST, and depending on the way we look at this, there is either some overlap or some synergies that can be established between CEMTEC and MARTEC. But let's have a look then at the research projects that are possible to establish at IST. So IST is located in the Lisbon metropolitan area, and actually we are based in Lisbon downtown, really close to the airport, and we are the largest Portuguese university with over 40,000 students. This is a view of our main campus in Lisbon. There is another campus in Oeiras, near the Escola Náutica. And the research groups at CEMTEC are 4: marine environment, marine structures, safety and logistics of marine transportation, and then my previous group, Marine Dynamics and Hydrodynamics. As we can see, the 6 main activities which are developed at Centec are ship maneuvering and control, dynamics of moor floaters, CFDs, 3D virtual environments and ship dynamics, and also full-scale trials and model tests. And finally, nonlinear ship motions, which were my field of expertise there. In particular, I worked in this topic of parametric rolling of ships. Now moving to the new research unit, to Martech. So in Martech, there are many research activities addressing multiple scientific disciplines, but basically at Martech, fundamental principles are applied in terms of thermodynamics and transport phenomena to study environmental and economical problems. So there is a great deal of mathematical modeling involved in this research, and the scales are multiple, meaning we can study a problem at a global scale, national, regional, or local scale, such as a river estuary. And over the years, Martech has been delivering a very extensive outreach. The Martech team members are listed in this slide. I decided to color in light blue my name just to highlight that I'm a new part of this team. And the team training is also quite vast. And more recently, 2 other fields have been introduced in this group, which correspond to naval architecture and offshore engineering. The research lines. So we have thermodynamics of growing systems. In this case, energy and organism growth are steady. And then we have the complex ecosystem models. In particular, I would like to highlight this MOID, water, and the applications which I'm planning to work. I decided to call those practical and eco-friendly applications. Then we have MOID land. We also at Martech do some sustainability assessments, as listed in these slides, includes greenhouse gases effects, and etc. So in terms of research lines, there is a clear grazing for sustainability within this group of researchers, and the group also is involved in defining public policies. In respect to the MOID modeling system, I will be in particular involved with the hydrodynamics. In this case, there are 3 activities that are planned: safe design of floating cages for aquaculture applications, weather routing for fuel saving, and search and rescue operations. Also, in terms of water quality, I will address this particular topic of oil spills pollution emergency responses on board ships. And well, here there are listed other applications of the MOID, but I will move to the next slide just to illustrate the working principles of MOIDs. So basically, this is a circulation model where physical processes are involved. And as we can see, the model is able to make predictions on turbulence, waves, and currents. And also, the model can also give predictions on water quality, water properties, and also the sediment properties within the water column, and all those physical processes which are described in this slide. But in terms of MOID applications, so we have this pollution dispersion, in particular the oil spills, but there are many other possible applications, such as hazardous algal blooms, forensic issues, etc. And I will pass to the next slide, showing the outreach of MOID. As we can see, we have over 2,500 registered users and 150 regular users up to 2010. Now probably we have more, and at a global scale, as shown in this slide. So the most relevant slide for me is this last slide, where there are basically two proposals that I would like to present to you. Within this topic of discussion related to the marine sim, the navigation simulator. So the first one is about oil spill responses at sea, and our proposal involves the utilization of this hydrodynamic model to model the transportation and also the fate of oil slicks at sea. So this would be a kind of added capability to the existing marine simulator, and this could be used to simulate the responses of a ship operator to the oil spill of many different type of hydrocarbons, and also different scenarios could be selected in terms of import, restricted waters, or even open sea conditions. After this slide, I will show you a graphical user interface that has been developed for this particular application, and which I believe can be easily replicated to Marine Sim. The second line of research that I would like to bring to you today is this one dealing with weather routing on board ships. Basically, because MOID provides forecasts of wind, waves, and currents. So basically, we can easily use this data and introduce an algorithm which can provide some weather routing in order to save fuel, to optimize the fuel consumption. And this can be actually carried out for basically three different types of ships. The most common ones are the container ship, the tanker, and the bulk carrier. Without further ado, I will finish this presentation and I will show you the application, which is available online. So basically, we can come to this menu and define basically what kind of simulation we want to carry out, starting from a new one. Sorry. I'm going to refresh this. So we select a spill emission, and basically it is the first menu is to define what do we want to spill. In this case, we can define oil spill and oil, medium oil. The density of the crude will be medium. So we move to the next slide, and we can, for example, select a particular location inside this grid. Let's have a location near the place where you are now at the moment. So we can pick up this pointer and define the location, the exact location. Now let's move to the next one. So the volume of crude we want to spill, okay, we can define this much, and the time of the simulation, and we are having an instantaneous oil spillage. So now the simulation will run, and after this, finish. I think it's here. Yeah. Okay, today the 9th is this one. Well, this is just an illustration, but depending on the tide and the current conditions inside the Tejo River estuary, the trajectories will be different, and then we can also decide which properties we want to follow up. For example, we can look at the surface floating mass or the surface area, and there is another window where these properties can be observed. Okay, well, this corresponds to the end of my presentation, and now I would like to have also your views and comments about these two proposals I have presented to you. Thank you.
Thank you very much, Professor Sérgio. We will have some possible questions in the future, because we have an email of the professor. So we are going to continue with the next presentation by P. Varten. He's an associate professor of University of Southeastern Norway, and he's going to talk about projects toward green development of ports. Thank you very much.
This one. No. Yeah, a little delay.
This is the day.
Have a delay, okay?
Yes, thank you. As I said, my name is Per Håvatun. I'm the associate professor at the Maritime Institute at the university. Those of you who are attending in yesterday heard about the research group training and assessment that Stephen was presenting. Today I'm representing the other research group we have in the maritime logistics. And what I talked about today is not projects we have as of today, but project proposals that we are working on, hopefully to get into Interreg projects, but also possible to put into EEA projects, because this is project that we in the end want to have into Horizon Europe proposals. So name of it, yeah, it's a lot of different names, but I want to show 4 different proposals we are working on today. The first one is this digitalization and integration of custom clearance. This is based on a problem we have today with the paperwork shipping companies have and ports and terminals have, where it's not compatible with each other from ship to the agent to the ports, and everything is done by paper. The whole idea is to make it as one EU single window. This is an EU proposal. They want this solved. So the whole idea is to have one system from the for the cargo loading the ship and to the customer in Europe, digitally, secure and blockchain, in order to be transparent and not tampered with. So what we have done so far, so far we done this, of course, is a mapping, because we don't know how it is exactly. We know that every company is saying that they have issues with the customs rules. Thing is delayed. Customer doesn't get out the container in time, and it's of course delays in the ports. So far we have said this is a COVID problem, but it's not a COVID problem. It is a problem with systems not talking to each other. So what we are going to focus in is of course the customer's documents. We're going to say that if they can be digitally integrated into one system, it will be easier for every part in it, the agent, shipping companies, the cargo owner, but also, of course, the government with the customs, to read it, to do it, to clear what they're supposed to do. And the aim is, of course, to have this clearance done when unloading. So the whole idea, now it has really not info. There it is. One thing we have to also look at is, of course, sample testing on import. By doing this digitally, it's easier to do everything every agency wants to do with it. One thing in customs, because this is fresh food, health and food society is coming into it. There's a lot of things that needs to clear our customs or goods in the system. And of course, automated forwarded, meaning that nobody has to do physical, it's just moved ahead. So this idea we have here is to make a single window together with ports shipping companies and cargo owners, and customs in Norway and Denmark. That's the plan. This is in fact an Interreg project going up, Norway, Denmark, Sweden. But the thing is that as long as we have a scale of Interreg, that scale can be used other places. We have Interreg, Portugal, Spain. We have the EEA grants. It's sizable the same, meaning that we can do this one together with Portugal, looking at it from a Portuguese perspective. And also remember that Norway doesn't have any large ports, doesn't exist. Our biggest port is in Gothenburg, and that is also a small one compared to the big ones in Europe. So just have this project in a large port will be very beneficial for us also. So this is one of the areas we're going into. This is digitalization. The next one working on is, I talked about this last time I was down here also, about green logistics and the traceability of CO2, being able to know what sustainable footprint all of our goods have. We know that customers need information. They want to know that they are buying product that is sustainable, that hasn't been destroying something. In the triple revenue system also, social, economical and environmental. So the whole idea is to answer of EU call on the digital product passport. The idea is that when we buy the product, we know its CO2 footprint based on what's really happened on the whole way. And the thing is that going back to that problem, saying what has really happened, we can't use numbers from the manufacturer of cars or anything. We have to in fact trace it in the system, in the supply line. So what we see is that the cargo transporter, this one, he has his direct outcome of CO2 for the cars, for the ships, for everything he does. But he has also to know about scope 2, that is upstream, and scope 3, the indirect one. Yes, he has a factory. How is that one heated? If that is a coal-driven power plant, that number should be put into the cargo this company is dealing with, because that's a very polluted place. And of course also all your subcontractors and upstreams, downstreams collaborators, what are they doing? Because if they're not doing it correctly, we can say that we are perfect here, not doing any CO2 footprint more than absolute minimum, but it doesn't help us because these people doesn't care. So in the end, everybody must help each other to be able to deliver down here the product with the footprint that is within the regulations. And also the idea is to say that if you can't comply, if your number is too high, then the EU system can in fact go back and say, we are going to tax the following area. This is too high, we're going to put taxes on it in order for you to change that part of your supply chain. And the whole idea is to, of course, get this into remove the really bottlenecks for the CO2. So what we are going to do is to follow what the trends are now. We know the change in purchase patterns are coming. We know that people want to buy really short travel food. They want to buy really low emission transportation. Not only said it is, meaning that the customer is demanding something. Politicians must do it. They're doing a lot of things by law. We know it's going to be another one in the EU now. And our goal is to help the companies in this one. The whole basic idea for us to help the companies to be a bit further on in order to comply with what we know is coming up here anyway. by digitalization, by transparency, but still also with a system that is not able to be tampered with, blockchain, and not able to be tapped for sensitive information. Because regardless of what we say of traceability and transparency, something is still a business secret and must still be a business secret. So that this is the way we're thinking about this one. We're focusing on optimized logistic process. We are focusing on how to map what we are doing, the processes and systems based on the CO2 footprint. And going back also to the last one, how to automate the whole documentation system also with this CO2 footprint following it. Our main aim when the day is finished is that when the product is leaving the factory, it has already a CO2 footprint on it. And when a customer buys it, the end sum is on it, being just added up on the whole way down. So this is a part of the same idea with an automated digital solution for the tracing of the goods. Both these two are regulations that will help cargo owners and importers to be in compliance. The third one we are doing is more back to ports and terminals. Because if the terminals are going to be into this system and be able to participate in the traceability, they need to be digital also. So the third part of this big, hopefully EU project is the digital terminals and multimodal transport systems, meaning that the digitalization is not only of the port, it is also of the people around. It is also about all authorities, and it's into the safe sea system that this EU is going to build this couple of next years. So this is the way we feel that the ports can make their system to put in their information into what we've already said is this total digital plan in connection with border control, maritime authorities, customs, and everybody else that needs to be part of it. So how can we do this one? It is the European Maritime Single Window initiative, saying that the EU wants a system that is equal, that is open source made, available for everybody in the maritime sector, where everything can be reported. Safe Sea, that is a system in Norway now, where the ship is already giving all the information for their arrival digitally into the system. This is going to be a European version of it. And that is the port's way of getting into the digital system also, because at the moment, the port is not primary use of it, it's a secondary use of it. So, but the thing is that this is also an EU plan. If we are doing it in Norway, Denmark, as we're talking about, we can also do this with Portugal, with Spain. Because I think it's important to try these ideas in as many places as possible. Small port, medium port, large port, differentiated goods, whatever we have, can it work? I mean, it's no problem for my whole port. We are doing steel, so that one is easy. We are going to put the whole system in this one into the 10th ID, this trend of technology enhanced network of Europe. Yeah. Safe Sea Net is part of it, because Safe Sea Net is something we have in Norway. EU want to do it. Norway is asked to be part of implementing it in Europe. But we're saying also it's safety, it's security, it's environmental also. But the most interesting for me, I see, is the last one there, the efficiency of marine traffic. If we are going to move goods from road to sea, the efficiency has to be really improved. At the moment, it's no, for us in Norway, if the container is off the ship in Hamburg and onto a car, that will never leave that car until it's in Norway. But we have to get that from a ship in Hamburg onto a ship and then to Norway. So efficiency, downtime, and of course, reduced prices in the ports and terminals. And then we're into this one, Environmental Ship Index. It's a good initiative. Norway has a long list of ports in it. Portugal is white, meaning that there's no port in Portugal in it yet. And Spain has one. This is a system where the ports give a discount to shipping companies that is applying within the rules of CO2, of other pollution, using land power if they can, reduce waste. If they're in compliance with it, they get a discount. And the idea is, of course, to strengthen this one, and of course make it harder each time to get this discount. So this is a way for the companies, not only ports, but also shipping companies, to help each other to reduce CO2 footprint by giving discount for the best practice. If it's going to work in the long end, it's very difficult to see, because yes, we have competitive advantage, we have the business models. But we know that ESC is going to be extended, fully integrated calculation. They're looking for zero emission discount, meaning that if you have zero emission, real zero emission, you get the maximum discount. And they will also start on a module for reducing noise pollution both from ships in ports, but also from ships in coastal areas. The last one I'm going to take is this is the project we have been working on lately. This is a master thesis done last year. We have it in our desk. We want to do this one more. We call it the Port Environmental Performance Index. The whole idea was he mapped all the KPIs environmental-wise a port can have, where it is possible to measure something. And the whole idea was that if you want to have a sustainable development of your port, then you must be able to show people that you really have a sustainable development. Because if people can't have information, why should they believe you? If you say I am good in environmental. Regardless of this one, the thing is that if you can show the number, people will assume it's greenwashing. And we know that the problem with greenwashing is enormous in the maritime industry, not only the maritime, but especially this one, where we are saying we are doing stuff, but if we really look into it, it's just, greenwashing. So his idea, this master student, was, is it possible to be moral in the sustainable development of ports? And he ended up with this, what they call the PEPI model. The PEPI model was 450 KPIs, where he said a measurement could give them an idea on how the port was developed, where the problem was, where they could improve. With the 450 KPIs, it's too big to have one big project, but we are thinking about just going down to small ones. So this year we had a master thesis that was looking into the ship-port interaction. Thinking about of all those here, which one is due to the interaction between the ship and the port, and who is going to take the cost of that one. One thing is, of course, the tug. That is the easy one. What about the pilot? We use the pilot boat to get the pilot out of the ship. Is that the diesel engine? Should that ship has the footprint of that pilot ship? You have the VTS is doing job. It's a radar. Radar is electricity. How is that powered? There's a lot of things you can think about in order to get all the measurement that is possible to see if this is in fact following the ship or not. And one of the findings we had with the master thesis today, was that a lot of emission from the transportation of the goods was the ship said not our problem, the port said not our problem, but the emission was there. Meaning that if we don't put the traceability on the cargo, it's a lot of emission just removed from the calculation. So this is an idea that we want to work on, that we go into small parts of it, take the number of the KPIs that we have here, and see if we can build new small project on it for master students, for bachelor students, and further on maybe for other. We had, of course, some findings from the master thesis that we have been working on. One of the problems with this one is, of course, each port is unique, meaning we're not able to make a template. It is also very complicated to measure, as of course they are, because we are talking about 450 KPIs. And it's a very poor definition of what is an environmental KPI. What KPI is in fact giving pollution? What KPI is just an economic one? And what KPI is just a number for the better scorecard to just tick off the work? And of course, knowledge is there. We need training, we need education, because people in ports and also the shipping companies doesn't really know what we mean about environmental KPIs and what is in fact affecting the environment of what we're doing. So it has to be systematic. We have to make it understandable for people, and that is also for the customers. So we said this is going into the customer ID of the whole transport of goods. Then I'm not going to do that one because I talked about it already. But I think more about the next step, because as I said, this is a master thesis. It's not with a research project yet, but we have some. We need, of course, some real life testing of it. We need to see if it's possible to implement and put in operation, and we would also make the system virtual, make it using of speedometers or tags or whatever system, so it's easy for a port to show the customers, look at us, we have green today. Our electricity is solar power today. We have no diesel engines inside that is less than D6. The ship is coming in is on land power and is using biodiesel fuel. If this is possible to measure for the car port, they can just use it as marketing. We are green. But of course, this is a live one. The next one is a ship coming in with a marine diesel oil engine, high sulfur. They will have a red number, but they have to explain that one also. Since we are saying a real time, real measurement, and transparent output of it. So this is, I think it was 4 different projects, ideas we are now working on in the maritime logistics, going into this idea about digitalization of the whole flow, big data putting into it, especially for the KPI system, and being able to not only measure, but give a number for your customer, for your clients, and for the government, in order to say that, hey, we want a discount for taxes or for something, in order to look, we are complying. The reason I'm saying the last one is that we know if we are going to have real impact for the environment, the company must be able to still have a business. And we know that if one company is having expensive but eco-friendly fuel and the other one doesn't, we know who is going to win that one in the long term. So that is my presentation for some ideas.
So let's proceed to the next speaker. Is Dr. Nune Lorenzo. Is one of the heads of the Collab More Atlantic Research Lab, which has projects in the area of maritime field, and is going to talk about research projects at Collab More.
Thank you.
Very much.
Good afternoon to you all. It's funny hearing both previous presentations, you touched two things that we are interested about. First, we use MoHit as a tool for modeling, and we are very interested in carbon and in carbon budgets and carbon neutrality. So I will address this. To be honest, I took the challenge from Luis, who I thank for the invitation to be here, also to present the collab even to our Portuguese colleagues here in the room, because okay, it's too small. Is that good? Okay, yeah. And so the idea, I'm not just talking about projects, I will also talk about the collab itself. I will start with that, and then I showcase some of the projects we have running on the collab. So without further ado, in a nutshell, we are not for-profit private association, recognized by the Foundation for Science and Technology here in Portugal as a collaborative laboratory. And also we are a part of the Portugal National Science and Technology System. What we want to do is basically combine tools from Earth observation, in situ measurements, numerical monitoring, modeling, data analytics to get to concrete answers to concrete societal problems in the Atlantic. We are about 13 members, so 5 companies from the new space sector. I don't know if you ever heard about CubeSats and small satellites that are being sent to orbit. 4 associations, I didn't do anything. 3 universities, so Lisbon University with Técnico, that the first speaker was from that group. Porto University, which is very strong in robotics, and IPL in Leiria, Polytechnic Leiria, which is very strong in a lot of stuff, considering, for instance, agriculture, food systems, and so on. We are based here in Lisbon, in Porto, in Alentejo, and in the central region, actually in IPL, in Peniche. And our biggest strength is the team. We are about 44 people, highly qualified personnel, which is strongly multidisciplinary. So the trick here is put people speaking the same language with different backgrounds, and then you can start moving ahead very quickly. I will not go onto this, but just to show you the profile of the guys we have people from space engineering, mechanical engineering, oceanographers, biologists. I myself am a geophysicist, geologist, naval engineers, and so on and so forth. Most of the team is master or PhD, and this is our biggest strength. We don't have infrastructure. We use the infrastructure from our associates. Then, because engineering is typically more for men than for women, in the past has been so, we are 60% men and so just 77% women. What is our approach? Actually, it did not change, but I don't know why it's not changed. Here it changed. I think it's stuck. I can show you the computer okay. So basically our approach is what I was telling you. We take Earth observation, in situ data, modeling tools, data analytics. We use machine learning on big data, artificial intelligence, and we try to get added value products, knowledge intensive. So basically we try to deliver services and products based on knowledge, based on research, okay? And apply it to different blue economy sectors. So most of what you said is of interest to us in terms of developing targeted applications to get to whatever result we want. This goes slowly because here change faster. Okay, take blue economy as a whole. Of course, we are not about building windmills offshore or doing, large scale facilities. What we want is to really connect and find the niche where we can operate with these tools to find solutions that link the different big areas of the blue economy, okay? For instance, using Earth observation for offshore aquaculture, we are into that. Or finding how to cope with resilience to climate change on coastal areas. We are into that. So with specific tools. Another thing that the collabs have, we are not the sole collab in Portugal, there are 36 collabs, different themes, is really trying to link innovation, research with enterprises and companies, okay? And how do you do that? Basically, it's not just about transferring knowledge, but it is waiting for the slide to change. But it's basically to bringing to the academia and to the R&D what the companies want. So speaking the common language of companies, and at the same time, bringing what's been created in the academia to the companies, okay? I don't know what's happening because it is changed here. But so imagine this as a circle from left to right, okay. So basically, 1, 2, 3, 4 are these ones. So identify pressing issues from the industry, taking them to the academia, say, solve it. Most of our PMEs or companies don't have research infrastructures or research teams. And so we can do research for them, contracted research, or we can bring to the academia the problem that they have to sort it out. The same on level 2, we can also cooperate with academia. On level 3, we can bring innovation from academia to bring the products and the services to higher TRLs and higher MRLs, so market readiness levels, and we can also consult to the industry. So our maturity cycle goes from this. We want to generate knowledge. We want to work on that knowledge from data intensive, to get to products and services, and from that bring added value to the market. So this is basically the circle. As soon as we are getting more and more value, this is feeding to the pipeline of, again, getting more data and more knowledge and more observables, study them, bring information out of the data, and go to the market. Our target areas are, I will not go into very much detail. I have, 15 minutes? Going to very fast. So we support blue economy activities like, renewables, offshore, like aquaculture, which is tendentially migrating to the offshore. We would like to get into harbors, into shipping. We have some products on that. We are focusing a lot also on coastal areas, because there are big problems in terms of climate change on coastal areas, and because most of the anthropogenic activity is very close to shore, with excluding, of course, shipping. And we also want to have infrastructure and data infrastructures to generate data to feed the pipeline. So basically, these are the 3 areas. Ocean stewardship, something that Professor Sergio showed in the beginning. We want to make it bigger and make it like a Lisbon Bay digital twin, where we bring, I'll show that in a while, atmospheric part, marine part, occupational part, and observation part, apart from models. Carbon neutrality and carbon capture from the services of the ecosystems and for the footprints of the activities. Coastal risk assessment and monitoring. Portugal is retreating. Everywhere in the Atlantic coast is retreating, but here in Portugal is a serious business. So we are measuring that using Earth observation and creating tools for the development of blue economy. Some examples very fast of the projects we are running. So some on observation side. These are specific projects with the associates. This is an unmanned surface vehicle done by SEI with our support on the command and control side. This is prone for transitional and inland waters. The evolution of this will be a coastal ASV, so unmanned system. These are some examples in harbor of Aveiro in the north and in Setúbal harbor here in south of Lisbon, a shipwreck and some scars of dredging. So we can use this kind of vessels to operate with larger manned vessels to make it more efficient to do the bathymetric mapping or the environmental quality monitoring or surveillance or whatever strategies you want to fit in. Another project we won, this was the FLAD Atlantic Research Award, was awarded to us last year by FLAD. FLAD is the Luso-American Foundation, so it's a 3-year project, and basically deals with the objective of having an Autonaut, which is an unmanned vehicle, which will depart from Porto and get to the Azores, measuring observables from the ocean, on the ocean, and especially being fed navigation real time with meteorographic processes. It will divert to whatever manifestation of these processes to study those processes unmanned. We are more ambitious. We want to go to the US. So stop in the Azores and continue to do with the US. This is a collaboration with our associate, Phil, on Porto University. Another project we are having is we got 1 year of AES data global and 3 months of live data. We want to assign AES tracks to NO2 plume tracks on vessels. We want to do that to really assess budgets in terms of carbon or in terms of NO2, in terms of pollutants and greenhouse gases, to really get to have a signature for each vessel passing on the Portuguese lanes, continental Portugal lanes, and also even in Lisbon Harbor, okay? Because there's no feeding, no power supply from Lisbon Harbor, so they have to be still running when they are on dock. This is just an example. So when you look at the Copernicus products and you see the plumes, they don't match AES tracks because you have forcing from the wind. So we are using models to model the diversion from the wind with the AES track to pinpoint which plume for which vessel and then identify the vessel, okay? This is in the slide that you are not seeing. And probably I'll go ahead. This is very slow, I don't know. Well, this is the idea. The slide will pass and okay, right? So in purple, you have the AES tracks. When you look at the AES tracks and the plumes from NO2, they don't match. Then you do the modeling with the winds, and you get you see it on the inset on the right-hand side. You see then that the plumes are generated by those tracks of those vessels. So this is just an example. Another example, and I'll move faster. This is optimizing feeding systems on aquaculture offshore Madeira for sea bream, where we started using the drift product from Sentinel, so with SST, so sea surface temperature. As you know, the growth of the fish is a function of what they eat, which is a function of water temperature. And so we were able to forecast and optimize the feeding process with regard to not climatic SST, but with modeled SST from Sentinel. Then we have the Lisbon Bay Digital Twin, which basically comprises an area. Normally, we tend to see what happens in the sea stays at sea, what happens in land stays on land. We want to change that paradigm in doing a digital twin where we can have the sea and the land together working as one. And this is the interface we just developed. Part will be running MOHID that we heard in the first talk. Part we are using our own downscale to really have temperature on forecast temperatures on neighbors in the Great Lisbon, metropolitan Lisbon. And this is to assist and help authorities in civil protection in case of extreme heat waves, which are getting bigger and more frequent. In terms of marine heat waves, which have impact on fisheries and on aquaculture. In terms of coastal overtopping, in extreme events when you have invasion of the seas to land water, to farmland or to urban fronts. And so taking these together, plus observables inland and at sea, will give us a whole Earth system approach in terms of modeling, in terms of perception of what's happening in reality. Actually, this has an animation. Let's move ahead. Now the process is using the released open data to track down. This is an open tool data, so everybody can use it. It's called CASI. And basically what we have is the evolution of shoreline across time. We are now developing a module with very high resolution, less than half a meter, for more commercial applications. Most of the Atlantic is not the northern hemisphere and is not fully developed, is not rich, and it has problems. So these are tools that enables us to get data from space. For instance, for bathymetry, this is an example for Babitonga Bay in Brazil, where we use optical multispectral images to derive bathymetry with well, not as good resolution as a swath bathymetry measured on land, on site, but even so gives you a first approach with high quality of the bathymetry in complex regions. Then we have a couple of products and processes for coastal management and for risk assessment. This is one of them. We use drones and 3D deformation models, point source 3D deformation, to evaluate with cliff retreat which areas are vulnerable, which areas are having rockfall or are risky. Recall that in Portugal, sometimes people die in the summer because they are at beach and the rock falls on top of their heads. Unfortunately, this is true, even with the warnings. And so this is a work we did for the Cascais municipality in Bafureira, which is a beach close by, to evaluate which areas are more vulnerable. Actually, I stop here. Okay, thank you very much.
Thank you. We are making a slightly shift in the program. We are continuing the call environment and digital banking of existing vessels by Miguel Costeira from Tecnoveritas. Thank you very much.
Agora, ali vai sempre aparecer só com um bocadinho de delay. Não é? Bem? Usar como preferido, como se sentir melhor. Vai aparecer. E tem só um bocadinho de delay.
Okay. Good afternoon. My name is Miguel Costeira, and I'm here to present some products and projects that one private company in Portugal called Tecnoveritas are doing right now. Let's see if it's possible to start. Não é um bocadinho, é muito delay. Okay. Okay. So let's start about the company. It's a small brief. It's a company, a consulting company in the field of naval engineering with more than 25 years of experience, and it's based in Portugal. We try to provide engineer solution and service mainly focused on emissions and energy management. And during its 2 decades of existence, we try to increase a robust research and development group, department. And our focus is to find solutions in pursuit for a more efficient and less polluting industry. And try to do our part on the green revolution. I show you some certifications, awards, and recognitions will appear. Yeah. We won a first prize on the clean shipping with one of our products. So we are now focused more on revamping existing ships, and why we are focused on this. The consequences of climate changes are increasingly visible across the globe. The society mindset is changing, and we are putting more and more pressure on political decision makers. And with these new laws and regulation that increasingly emerge, we think that the industry needs to change and need to change very fast. But in the last decades, with globalization, the worldwide economic growth put some pressure on the development of new new fleets. So we now have an existing fleet, relatively new, but not comply with some rules and regulations that we are producing right now. And to change this, it takes a lot of time if you want to change old ships for new ones. So we think the best solution is to update the existing ones, revamping these existing ones. So the final goal is to achieve ships that operate without emitting any type of polluting gases. And for that, it's necessary to become more energy efficient, and they have to use a new type of fuel, what we can call a clean fuel. To achieve this, we will have to pass for a transitional phase. And for that transitional phase, it's the most relevant points are improving energy efficiency, and we think with the increase of implementation of monitoring systems that allows obtain accurate data from all ship systems, and the increase in board digitalization, process and work with this data help to take some positive actions, so the crew can improve the ship efficiency, and reduction of polluting gas emissions with use of low sulfur fossil fuels, biofuels, and gas treatment systems to reduce NOx, for example. We think to be possible for all the parties and for the owners to have the encourage to change their existing ships, they will need some support, financial supports, penalties for NOx taxes, and some of that. Because without that encouragement, they will not do nothing at all. So we try to develop some solutions. We can separate here some digital revamping solutions and some environmental revamping solutions. I want to start with the digital ones. We think that the ships needs to implement more and more tools to monitoring all the things in all the systems that they have. We work in one monitoring system. This is done by us, and this is a dark thrust speed and power meter system. And this tool gives us information that for possibility to optimize the ship performance. And then we develop two digital tools that we can say that complement each other. We call a view system. It's a onboard data acquisition and processing. And the BOEM, it's a business assurance tool that link between fleet and shore. I want to show you some image from our view system, some possibilities. Stream optimization, flow management, reports, automation reports. And then our BOEM system have this kind of parts, models, that we can put it together or only buy some of them. Performance management, maintenance management, all of this. And we are now under development for a tool, a new model for a voyage optimization and crew management. We are trying to optimize the weather routes, minimum fuel consumption, and so on. This is in the next slide. You will see some image that what you can see in any browser. This is the aggregate information of all the systems in one ship. Mission management, tree system. This is completely personalized for clients. Its performance, CEI, and correlation CEI with ship speed, and so on. We think this kind of fleet digitalization will help to improve efficiency and so to reduce a little bit the carbon footprint. And then we are involved in some environmental revamping solutions. One of them is the installation development and installation of SCR systems, selective catalytic reduction systems. Right now, our biggest markets is the cruise ships that time to sail to Norwegian waters, because the Norwegian waters are the most restricted ones right now. But if we think and we know that the ECA areas will be more restricted in the near future. This is the next slide. The idea is to show you very summarized the process to implement a system like this. So we start doing3D scan, and we have the point cloud information. This is the ship without SCR system. With this kind of information, we can model the existing deck line, and then provide and try to put a new system. Then we need to do all the calculations, back pressure calculations, and so on. Sometimes it's very difficult to do this kind of implementation because the space it's not in our favor. Okay, this is some real footage of one system that are already prepared, but this is in the phase of construction. The last one. Yeah. This one, it's the finalized housing. This is a sensor to monitoring the emissions, NOx emissions. It's a Danfoss sensor, but you cannot see it. Okay, for another topic, we considering that the dimensions and the energy needs of a ship need some solutions that for other type of vehicles it's not makes so sense. For now, the use of batteries in a lot of type of ships, it's not a viable solution for now. The solution, in our point of view, is to use a clean fuels. With a clean fuel, we need to produce the fuel in a really clean way. And then we need to that kind of fuel have to be available in all markets, or most of them, and have to be financially competitive, which now it's more easy because the diesel it's that's some records, and hydrogen, in our opinion, turns out to be one of the most easily that meets all these requirements. So with this conviction, we are currently as a set of projects under active development, including 3 main stages: production, consumption, and transport and storage. For production, we are betting in a alkaline water electrolysis because of the cost production. It seems for us a good solution. This is our the next slide. It's a prototype that we developed, and we are now in phase of tests. We have first results. This one. For the consumption, we believe the existing fastest solution to turn existing ships from traditional fuel consumers into hydrogen consumers will be through the conversion of installed engines. We know that the fuel cells are now in a great development, but we think it's very expensive to change all the engines for fuel cells, and not so feasible right now. Our company starts to do this kind of reconversions in 1999, and we are now developing a project to convert a large marine engine. This one, it's an image that's with a Wärtsilä engine we're converting. And now the last one, it's the transport and storage. It's one of the biggest problems for the hydrogen. The high pressure that the more traditional ways of transport use have some problems. And we are now developed some solution with a liquid oil hydrogen carrier. It's under development. We are starting to have some good results, and let's see. This is the next slide, the test bench that we use. And in the left part, it's the oil hydrogenation. You cannot see the bubbles, but yeah, we have the oil with some hydrogen inside. So that's it. Thank you.
Just let me go into see what's happening with the
Grande parte do nosso planeta é oceano. Dá-lhe a sua característica cor azul. É fonte de vida, de energia, de riqueza. O mundo tem vindo a perceber-se de fatores que afetam estas fontes essenciais e requer ação para garantir a sustentabilidade dos oceanos. o desenvolvimento da economia azul, nomeadamente nas áreas da tecnologia, formação, infraestruturas e regulamentação, dará uma resposta inovadora à importância que os oceanos têm para a vida do nosso planeta. A formação de recursos humanos qualificados é essencial para garantir a sustentabilidade dos transportes marítimos, fundamentais para o desenvolvimento da economia azul do futuro. Segundo a Associação Internacional BINCO, em 2025 serão necessários pelo menos 150 mil novos oficiais da Marinha Mercante para responder às necessidades do setor a nível nacional e internacional, o que requer a adoção de medidas que fomentem o aumento da formação de grande qualidade.
Na ENID, a nossa missão é formar oficiais de marinha mercante para os futuros desafios nacionais e internacionais, bem como outros quadros para o setor marítimo portuário. É um objetivo estratégico da escola, que já conta com 96 anos de existência, contribuir para o desenvolvimento da economia azul, através da formação de profissionais altamente qualificados e preparados para as mudanças no shipping. A escola rege estritamente pelos altos padrões da Convenção IMO-STCW e EMSA e, como tal, promoveu a criação do projeto Maritime, tendo em vista apetrechar-se de um conjunto de modernos simuladores marítimos. Queremos enriquecer a nossa vasta experiência na área da formação marítima através da atualização e modernização da capacidade instalada de simuladores da escola, intercâmbio de experiências de formação, investigação e colaboração com instituições de referência na área marítima e participação em projetos internacionais. A aquisição de equipamentos de simulação de vanguarda é um meio para desenvolver processos de inovação na economia azul e de capacitar os recursos humanos da ENI, com conhecimento altamente especializado na área marítima, utilizando meios pedagógicos inovadores.
O Marine Sim é um projeto desenvolvido em colaboração com duas universidades norueguesas dedicado à aquisição de simuladores marítimos para formação dos estudantes dos cursos marítimos e requalificação de oficiais de marinha mercante, aliado a ações de melhoria da capacitação em formação e treino marítimo de docentes e estudantes, onde se destaca a realização de seminários, novos cursos e o desenvolvimento de projetos de cooperação. O Marine Sim visa permitir a aquisição de simuladores de vanguarda, nomeadamente simulador Full Mission, visual de navegação com cartas eletrónicas ECDIS. Simulador Full Mission de instalações propulsoras de navios. Simulador de navegação por radar anticolisão ARPA. Simulador de treino com modelos de instalações propulsoras de navios. Simulador de treino de embarcações de sobrevivência e salvamento. Simulador de carga e descarga de navios-tanque petroleiros, químicos e de gás liquefeito.
A ENID, em conjunto com os seus parceiros noruegueses NTNU e USN, orgulha-se de fazer parte do programa Crescimento Azul e compromete-se a aumentar a investigação e promover a educação e a formação na área marítima.
be a very interesting call. Thank you very much. Please.
Good afternoon. First of all, I want to thanks for the invitation. I hope that it goes everything well with the projector. Is it working? Well, because I'm seeing a different thing in my laptop. Okay. It's still a little bit delayed, but I hope it works. So my name is Francisco Barbosa. I'm responsible managing director of Navatagos, which is a small shipyard here in Lisbon, in the south side of the river Tagus. I'm going to talk a little bit about our group and Navatagos, then about the ferry boat, the project EFP 37, and then the future market outlook of this type of vessels. So who we are? So Grupo ET is a family-based, third generation, family-owned company. Like most of the companies, or a big part of the companies in this kind of sector. So it was established in 1936, and I will pass quickly. So we are on the third generation. We grew up a big part by mergers and the acquisitions. Everything in the maritime and portuary sector. We as group, our vision is to lead logistics and maritime inland waters in Portugal and overseas, wherever we are. And our mission is to give integrated solutions to our customers. And that is something that differentiates us from the different competitors that we have in this sector. So we are a Portuguese-owned company, 100% equity. We have a turnover of more than 200 million euros and more than 1,100 employees. We are in different places in Portugal, Belgium, in Europe, in Africa, in Cape Verde and Mozambique, and in South America, in Colombia and Uruguay. Our company, as I was saying, operates in maritime and portuary. So we have port operations. We have port terminals here in Portugal. We have inland waterways. We have the biggest shipping agent here in Portugal. We have logistic, we have engineering, and we have shipping. And all of this is most or a part of our business is not only inside our company, but outside to give different solutions, integrated solutions to our customers. So regarding engineering in the engineering area, we have two shipyards, Navatagos, where I am, and Naval Rocha, which is also based in Lisbon. We have a maintenance and repair company, Naval Prime, with two workshops, and we have, let's pass the next slide. We have a ship management company, which is responsible for the superintendence of 45 vessels. Half of it own fleet, the other half from different customers' fleet. And we manage also crewing. About Navatagos. So Navatagos is a shipyard which makes construction and repair in the south side of the Tagus River, so south side of Lisbon. We have constructed more than 14 vessels. We do almost, well, between 40 to 50 annual repairs. So we don't have any dry dock, but we have ramps, which enables us to bring the vessels to dry dock, to do the jobs. So about the project. So we were challenged by winning a contest to build a 100% electrical ferry boat. It is as main feature as was building something state-of-the-art, different from what we usually do with combustion engines. We thought that it was a big mark for our company, but also for the country. We are one of the first shipyards in Europe to build such a vessel. So we decided also to include some design to mark and to make a statement about this kind of vessels. And I believe that is, we were thinking also about the user's experience, as this kind of vessels are being developed by municipalities, by politicians, and they want also to sign and to mark and to give a good experience to its customers. So we pushed and we brought into this project something that we made different. Normally it's engineers that are making the vessels. We brought some designers also with experience from other type of transport, like airplanes, like cargo, but also trains, and give the same kind of experience in such a vessel. So this was the work that they have done, and it was very different from our initial idea from the engineers. So they brought here some design that gives a little bit the sense of lightness and dynamic of an electrical for an electrical ship. We brought two companies, two different designers. One which was expert in the segment of yachts and super yachts. Other one which was expert in public transportation. And they worked together for the first time, and they made, which we believe it will be one of the most beautiful electrical ferry boats in Europe. Also, not only the external outlook, so we are defined also internally to have a different experience of public transportation. So we design a little bit like a lounge, like a saloon inside. And we hope that as soon as it's ready, that the customers also give a good feedback by stating that this is not only something that doesn't make noise, doesn't make pollution, but gives another kind of experience for this kind of transportation. So the main characteristics of the vessel, so it's a 37 long vessel with 9 meters, 9.2 of beam. We have a propulsion of 2 times 200 kilowatts, batteries capacity of up to 500 kilowatts, the capacity of 260 passengers and 19 cars, which means that the vessel itself is quite compact, which gives us an extra challenge, which is to where to put the batteries, because it's a big amount of space needed to put the batteries. But we were able, and the battery suppliers are also making some developments to have better capacity with lighter weight and lighter size. So we are receiving the state-of-the-art batteries that there is in the market with the main features that we need for the vessel. Another challenge is, of course, that the rules. The rules, they are quite new in this kind of vessels. So we have the classification society of BV, which has already rules for battery systems, which bring also different features for this in terms of safety and security for the vessel. So, and then in terms of rules, we are also using the ESTRIM, which is the European norms for inland vessels. For this project and to have a good reliability of the vessel, we have chosen and we make a market research to choose what was in the market and who were the suppliers who could bring to our system the most advanced solutions, and that brought us more confidence to operate this vessel. And we have chosen the Delphos system, which is a huge company in the north of Europe. And we have used also batteries from SPBS, which is a very big company from Canada and Germany. And then we integrated these solutions with other players. The assembly and construction, it is in the next slide, which should be in a moment. Okay. So this is some pictures 1 month ago from the shipyard. So the vessel is a little bit more developed than this, but you can see the propellers with our azimuth propellers from VET. And the vessel itself is a steel vessel, so not very different from other vessels that we have built in our shipyard. The only difference is that instead of having all the mechanical parts, we'll have all electrical parts inside of the vessel, most of them electrical. One of the big challenge of this kind of vessels is the charging systems, because the requirements for charging are quite huge. The battery's capacity are not as big as we would like to have, which means that in every passage or every time that the vessel has opportunity and time to make some charging, we shall use it. And regarding other challenges, how to operate manually with the crewing, because the cables are quite huge and quite heavy, and it takes lots of time. We would lose lots of time by doing it as manual connection. So we decided to go to automatic systems, which means that the vessel, as soon as it comes to one of the side, this is operating in a river, but it will have on both sides of the river charging systems, which will enable to charge very quickly. So the connection here, that we have an idea, is about 30 seconds. If it would be manually, it would take more than 5 minutes. And here, a minute means lots of battery to be charged. So we are using, and we decided to use automatic connections, which we believe that it's the best solution for this kind of vessels. In terms of batteries capacity dimension, important is to notice that the batteries should operate between 20 and 80% charging in order for their life cycle to be more over than 10 years, which is one of the demands of our customer. And the requirements from the battery system to enable such a long lifetime for the batteries is that it should operate between 20 and 80%. And as you can see, and this is a time schedule, we have 26 trips per day to do it. And every time that you see the curve going up, is that it is being charged. So if we have more time to charge, more time stay in the vessel, in one of the shores we charge, we will use this time to charge the batteries as much as we can, so that we end the day with the batteries lower, but then we will charge again during the night. We have a special request which is more demanding, which is some holidays from the municipality that they need to make more trips, and this brings more charging. As you can see, the batteries level is a little bit lower than the normal situation of the 26 trips. So the market outlook, just hoping to change the slide. Already changed my computer, but okay, market outlook. Why are we investing so much time in this kind of vessel? Because we see it as an opportunity. The market, it's a blue ocean market, so it's something new. We feel and we believe that due to all the decarbonization rules that are coming up, that more and more of this type of vessels will occur. And if we look to the market research, we see that the market will rise from 4 billion to 16 billion euros, and most of them will be this kind of vessels, either hybrid, either electric, or other solution like hydrogen or something. So we are working on innovation to adapt ourselves and our team in terms of engineering, in terms of having an ecosystem of players, suppliers that enable us to give the best solution in the market that is available for our customers. Yeah. And to give you other example, we are not the only ones working on this. Some other shipyards are working on this. This is not being built by our shipyard, but as repair company, we will have for sure also to repair from other customers at Transtejo, which is the public service of fluvial transportation in Lisbon. They are acquiring 10 of these catamaran vessels. So our competencies that we are working in construction will also be important to make the maintenance of these kind of vessels. And I believe that Lisbon will be a hotspot of electrical vessels in 2-3 years' time by having 10 of these vessels operating here in the region. It will be for sure in Europe one of the places that you see more electrical ferries in the same place. And finally, obrigado for the conference, and see you next.
So let's start to the second panel, Maritime Associations and Administrations. And the first speaker for the extension of the Portuguese continental shelf, challenges and opportunities. Please, Pedro, thank you very much.
Thank you very much, Luis.
Thank you.
Thank you very much for your kind invitation to be here and to speak a little bit on the project. The first one. So I'm quite lucky that I have the opportunity to coordinate this project, the submission of the Portuguese continental shelf to the United Nations. And I will leave some message in terms of opportunities and challenges. Just a geographic scope. So we are the westernmost country of Europe, which brings some disadvantages, or a lot of them, but also brings some adventures. It's because we are facing the Atlantic basin, and somehow this is what happens with Norway as well. We are sharing, in fact, the common interest in terms of the maritime space and in terms of the Atlantic Ocean. So this is the submission that Portugal did to the United Nations, to the Commission on the Limits of the Continental Shelf. And this orange region represents the extended continental shelf, which means the seabed and the seafloor beyond 200 nautical miles. And we did that under the Convention, United Nations Conventions on the Law of the Sea. And this is what we are dealing with. And to do that, we need to of course, to gather data. And one of the challenges was, in fact, to map the seafloor. We need to have a lot of information in terms of morphology. And back in that time, the challenge was to equip the available vessels, which were the vessels from the Portuguese Navy, with multi-beam systems in order to map the ocean and in terms of a lot of the deep ocean. And this is the result. You see here the white or gray areas was the area that was mapped between 2004 and 2008. And here in the pinkish color, the mapping that we did between 2008 and 2017. This is, of course, a good contribution for the science decade of the ocean science and also for the seabed 2030. And of course, the goal is to go from the low resolution bathymetry to high resolution bathymetry, which is one of the requisites in order to proceed with this kind of project. Another challenge was also the fact that, well, the continental shelf and the extension of the continental shelf was initially so to this kind of situation where you have the transition between continental crust and oceanic crust. And there you have this typical morphology, you have the geological continental shelf, this area with, well, less than 200 meters of water depth. Then we have the continental slope that represents this transition between the continental and the oceanic crust. You may have the continental rise, which is the accumulation of sediments that have been eroded of the continents. And this was, in fact, the theory around the continental shelf and this project. And in fact, if we go to the convention and if we go to the guidelines, scientific and technical guidelines that were issued by the Commission on the limits of the continental shelf, and if you took all the examples that they have in the guidelines, these all represent transitions between oceanic crust and continental crust. And well, it can be very complex and varied, but in all of these schematic diagrams, you have this kind of transition. So if we look to the Portuguese geography and to our country, what happens is that, in fact, we have a mainland, the Portugal mainland, where we are now, that is, in fact, based on continental crust. And then, if we wait a little bit, we'll see that we also have two archipelagos. The Madeira archipelago, near the continent, and further away, the Azores archipelago, which in fact, they lie on oceanic crust. So here we have this kind of the normal transition, the continental crust and the oceanic crust, and we have this typical morphology where in fact it is a bit more complex due to the amount of seamounts that we have there in this region. But here we have the Madeira archipelago and the Azores archipelago, which correspond to land territory that is in fact built on oceanic crust. So the challenge here is to, well, in some way to apply the criteria that is envisaged in Article 76 of the United Nations Convention on the Law of the Sea, and to apply this to these particular cases, to oceanic island. And in fact, what happened in oceanic island, that we'll see in a minute or two, is that we don't have this typical morphology that we have here that bounding the continental crust. So in terms of oceanic island, we usually have a very narrow shelf, and then we have an upper slope and a lower slope, And well, and the difficulty is to establish the transition between the lower slope and the deep ocean floor. There is a geophysical signature that is particularly evident in terms of oceanic islands that we can use. And of course, we also use this difference in geochemistry because the oceanic crust, the deep oceanic crust, is typically formed by what is called MORB, which is mid-ocean ridge basalt. And the ocean islands have a different geochemical signature, and they are called OIB, which means oceanic island basalts. And of course, we also took benefit from recommendations that were issued by the Commission to other states. And notably in the Atlantic Ocean, we have the recommendations to Iceland that were issued in 2016, to the Ascension Island, which is a territory of the United Kingdom, back in 2010, and Bouvetøya or Bouvet Island, Norway, the Norway territory, in 2019. And this is quite interesting because Norway did it very, very well, succeeded to have a favorable recommendations in terms of this territory. Bouvetøya is here. And in fact, you had quite a success to extend the continental shelf beyond 200 nautical miles and even beyond the limit of 350 nautical miles. And we have here the Bouvetøya Island, with these dots represent samples that were taken in this territory. And you see that they have this typical signature, which is different from the mid-ocean ridge basalts. And you were able to include in the continental shelf the Shaka Ridge, which is really far away from the territory, and basically because we were able to collect samples from the deep ocean floor that had the same geochemical signature that we observed in land. And if we take usually in geochemistry, and I'm a geologist, my background in geology and geochemistry, usually we take two elements like two rare earths like lanthanum and samarium. And if you see the slope of this, the trend of these samples, they usually have ratios of lanthanum and samarium above 1. And these basalts from the deep ocean floor usually have ratios because the slope is different, lower than 1. And this is why you succeed so easily to extend the continental shelf towards the Shaka Ridge. So we needed samples. And in order to do that, we acquired in 2008 the ROV that we just visited this morning, the Luso ROV. And in fact, my good friend Nune Lorenzo was one of the responsible people, one of the persons that was responsible for acquiring this to Norway, to our remote system. And has been a very nice history. So we succeed to dive with the ROV because what we intend to do with the ROV. Okay. And now, okay, you can see the ROV moving down. And of course, we wanted to collect sample in preferable regions around the island of the Azores archipelago, of course, and also in more remote regions in order to show that the geochemistry signature of these samples are quite similar to those that we observe inland in the Azores island. And so we sampled these areas that we'll see in this yellow ellipse here. So we went to these remote areas really far away from the land territory, and we were able to dive with the ROV. And of course, we wanted to collect these geological samples, but because we have multidisciplinary teams on board, because it is expensive to go there, and we have the vessel, the time to do it. And of course, we also observe a lot of interesting things, like, for instance, the Serreta eruption between 1998 and 2001 was the first time that we saw that underwater, visually, with the camera, with the footages that were taken from the ROV. And these are pillow lavas because when lava enters in contact with the cold sea water, it cools quite quickly, and it gets these rounded structures. And we were able also to collect these kind of pillow lavas much deeper at 1,100 meters, and here in 3,100 meters below the water surface. And in fact, we we were able to show that these samples have the same geochemical signature that we got in the Azores Island. And of course, we have these multidisciplinary teams on board, and we also take this advantage of having the ROV to collect information on the marine ecosystem, because it is also crucial to have this information, not only the water column, but also the ecosystems of the deep ocean floor. And we were able to gather a lot of information that was used to feed scientific projects, also to deliver some data and some information for some commitments that Portugal has to fulfill to the European Commission, namely. And here, for instance, this animal, this kind of squid, it was known, but it was never observed swimming at those depths. Here we are, I guess, something that 2100 meters deep, and it was the first time that this animal was observed swimming in this kind of habitat. So the opportunities, of course, you heard this morning is to strengthen our capability to work in the deep sea. So we want to develop the system. You heard this morning that we were able to develop a new electric bottle to have more possibilities to link more instruments and more sensors. This is one of the goals. Of course, we also want to develop this full capacity in terms of the video footages, and we are changing and replacing our HD cam with a new one with a 4K camera in order to have more resolution. Also, we are now trying to develop and to install the multi-beam system in order to have very high resolution data, and also to work and to improve our positioning with the inertial navigation system. And this is our main goals for the near future. And the ROV was the core of some partnerships and collaborations that we have with Portuguese institutions and universities in order to develop this system as much as we can, and looking also to the interests of these partners. And I'm getting quite close to the end. We'll end with this beautiful image that probably you won't have time to visit. This is the so-called coach of the oceans that you can see it in the Coach Museum in Lisbon. This car was built in the 18th century and was sent to Rome in 1716, I guess, by our king, in English it would be John V, to the Pope in Rome, and to impress the Pope. And this is the coach, the car of the ocean. What is interesting here is you have these two men, shaking hands, and in fact, the one to the left represents the Atlantic Ocean, the one to the right represents the Indian Ocean, and in fact, this represents the achievement by the Portuguese sailor when they reach what was called since then the Cape of Good Hope in South Africa. And in top, you also have the representation of the 4 seasons of the year. So you have here the summer with this woman, with a bunch of wheat or something like that, and the spring here with flowers. And in fact, we know that eventually this representation of these seasons is being threatened by the climate change. And climate change is it's putting a lot of pressure in vegetation, of course, in our world. And so I would say that the main challenge for the future that we need to track and keeping to develop is to look to the interactions between the geosphere, between the hydrosphere, and between the atmosphere. And this is something that the Plus Atlantic Lab is also looking for, and this is really the great challenge for all of us. And of course, I will end up because we are in this particular season of parties in Lisbon, and I would suggest you to get to know about one of the main products of our blue economy, sardines. And you can go to Lisbon tonight, and you will see a lot of parties and in the street and people eating sardines with the bread only, and it is very typical. Thank you very much.
Oh, let's continue with the next talk. Portuguese maritime technologies industry profile and perspective and challenges by Mário Pinho, Secretary of the Naval Industries Association. Thank you very much.
I'm going to jump to the next one to see if the time helps me. Thank you for the invitation. We are the national representatives of the shipbuilding, mainly shipbuilding, ship repairing industry and associated companies or sectors. We've been created in 74 following a very old institution called Grêmio Nacional da Construção Naval, which is, let's say, the ancien régime type of organizations. So it was revamped and created in 74, and it represents mainly shipyards, as I said, both new building and ship repair, and also engineering offices related to the naval industry. AIN is member of three main associations: EIP, the Confederation of Portuguese Businesses, is a member of the General Councils and participates in meetings of the Strategic Councils of Economy for the Seas, Industry, Energy, Environmental, and Digitalization. He's also a member of Fórum Oceano, which is the association that represents the Portuguese Maritime cluster, and is member of the Sea Europe Shipyard and Maritime Equipment Association, which is a merger between two associations that existed in the past, one representing shipyards and the other one representing the maritime equipment companies, which has been merged, and within Sea Europe, which represents the, let's say, the maritime technologies industry's interests with the European Union. We work mainly in two groups. It has two or three more working groups, one related to naval and defense ships. We are more involved in the working group that represents ship maintenance, repair, and conversions, and also the social dialogue, which makes us participating in the EU social dialogue committees, together with Sea Europe and Industry All, representing the unions. The shipyards and the companies are spread all along the coast of Portugal, from north to south. There are shipbuilding yards, maintenance and repair yards, vessel designs and engineering companies, research and development very much linked with the engineering, companies that dedicate to manage and design infrastructures, materials and equipment suppliers for the marine field, and also classification societies. There is a concentration of companies in the three main areas where the larger yards are: north in Viana do Castelo, center south around Lisbon and Setúbal, and then with smaller crafts there is also in the Algarve area. The sector, and we are using values, they will show up. We are using data from the National Institute of Statistics of 2020. I will go ahead, the figures will show up shortly, I hope. Annually, the turnover is around 430 million euros. As for all the sectors in the Portuguese industry, you will see that there are a lot of companies, 420 companies. Just to give you an idea of the profiles, and this is similar for our industry and also for the other Portuguese industries, 80% of the companies are micro companies. 15% about are small companies, and 2% are medium-sized companies and 3% large companies. So there's a spread of a lot of companies with not so many employees. In total, directly employed are about 3,750 people working. On the shipbuilding side, 275 companies dedicated as their main area of business for shipbuilding. They generate around 233 million euros, and they employ 2,135 people. In ship repair, 145 companies, 197 million, and roughly 1,600 people. These are some of the examples of what has been built in Portuguese yards, and just to give you an idea, the main yards we have in the Northwest Sea that dedicates to expedition cruises and river cruises. This is a company that was created in 2015. They took over the state-owned yard of Vienna, and they dedicate mainly into these three types of vessels. We have Navatagos. There's very little I can add to what Francisco told you shortly ago. They build small marine crafts and tugs it's not river cruises, but it's something that we call in the Portuguese sector Maritime or turísticas. This is maritime and touristics. Let's call river cruises. It's simpler, everybody knows, but they are smaller than river cruises. There's Navalria, which is a company that is it's changed a lot. Navalria, which works in the same group of West Sea, belongs to the same group. They build river cruises as a spin-off of what West Sea cannot build. Atlantic Eagle Shipbuilding, we hope that they will build ferries because they are stuck since 1 year ago with one ferry for Timor-Leste. So we hope that they can bring it back to surface. And then there are smaller yards. These are just 4 or 5 examples of companies that are building small ships, usually around 30 meters long, supporting fishing activities, agriculture, and recreational crafts. Portinav and Nautiber in the south, and the others more up to the northern area. Maintenance and repair, we have a few flagship companies. The largest one is Lisbon, which is located in Setúbal. If you went walking around Lisbon, you could see on the south bank of the river still a gantry crane with the name of Lisbon. That was the old yard that has been deactivated 20 years ago, but the gantry crane is still there. Lisbon operates 6 docks, the largest one being 450 by 75 meters, which means that they can accommodate most of the vessels working in our seas. West Sea with 2 docks, the largest 203 by 32. Navatagos, which belongs to the ETE group as Navatagos, has 3 docks, and the largest one is 180 by 23. Navalria, again, two docks, one floating, one graving dock. The largest one is 104 by 18. The smaller yards, which includes the starting off with Navatagos as a slipway that they can accommodate vessels up to 100 meters long. And we have a dedicated, let's say, Navy yard and research vessels, which is located here in Lisbon with 2 docks. Astral 08 is a commercial company that exploits and manages the Navy shipyard. They are, range from servicing ships, Navy ships, from surface ships to now also the new submarines of the Portuguese Navy. They have entered into a very large investment project with the German builders to be able to do the maintenance themselves and hope to saving some money to the Portuguese government, and also acquire in technology that they don't use so far. Moving along, the smaller ones with slipways and travel lifts are mainly servicing the fishing fleet and recreation vessels. In the suppliers of equipment and services, I'm going to talk about one of the companies that you have heard about, Tecnoveritas. You also heard about Veranavis, which is cooperating with Navatagos in the building of the electrical ferry. They are dedicated mainly to, and Alma Design as well, they are dedicated mainly to design, engineering services, and research, as you have seen from Tecnoveritas projects. They do all sorts of design and engineering, from the more sophisticated to the more simple production drawings. Supplier companies, just to give you some names. Amongst a lot of them, they are mainly suppliers of industrial services, which is the case of Sadaship, Aerotech. They all in the Lisnave yards. They surface treatment like decor, mechanical equipment fabricators, and also workshops like Olimar. So there's a structure around the yards that supply services that are needed, as well as Hotelis, for example, which is a supplier of accommodation outfitting. Some recent highlights on the new building, and the slide will show up shortly. Westsea delivered the 3rd polar expedition vessel, and is working on the 4th one. We hope that COVID impact will not impact on the extension of the fleet of Mystic Cruises, which is planned to have another 3 of these built. These are expedition cruises that are navigating from the Arctic to the Antarctic. Usually the target would be to explore the Antarctic cruise market. I don't think you're going to see here it is the World Navigator. This is an example of how a partnership with a client or with a customer can boost your production. They started cooperating with the river cruises vessels, and they were challenged to produce these ones, which they've managed to complete. The next highlight, I'm not going to, let's see if at least if the slide shows up, I'm not going to take a long time, because it's the electric ferry that Navatagos is building currently, which is for the industry a landmark, because it's both a sophisticated design project compared to what has been done so far for ferries. And it's, of course, the first electrical driven ship that is going to be built in Portugal. here it is. It's basically, this is going to operate in the Aveiro Harbor, connecting to a peninsula area with the mainland. In maintenance and repair, and you can see here, this is a Norwegian vessel. The design is you cannot make a mistake. Only the Norwegians build vessels like this, or design vessels like this. And is a research vessel used in research of the ocean bottom. And this one, unfortunately, I didn't bring the picture, but it was a challenge to squeeze her into the dry dock because you have a couple of meters on each side. So it was not, and the shape doesn't help. The riggers are not used to vessels with this shape. But we're trying to diversify. Lisnav is one of the leaders in ship repair in Europe, but traditionally it was tankers, bulkers, container vessels, and recently they're trying to jump up to more sophisticated vessels. And Remform Atlas is one of the examples. They are also handling. Speaking of the Norwegian market, DP shuttle tankers and gas carriers, and they have a very good relation with the major ship owner nations, and Norway is included, as well as Greece, for example. Jumping again, some of the highlights, the slide will show up, but I will start to keep it as short as possible. Using their shipbuilding experience and entering into green shipping modifications, West Sea has successfully installed or modified a couple of vessels to use LNG as fuel. They hope that this project will impact on a reduction of 30% of CO2 emissions. I believe that is going to be very close to that. Or maybe even higher. This project is with two ferries that operate in the Mediterranean area and the Canary Islands. Again, this has very much to do what Technoveritas spoke about earlier. This was an example of where their SCR systems were installed in a ship. This was a Norwegian cruise ship that was bought by a Portuguese ship owner, and it has been converted to. I think it was already named Vasco da Gama when it was bought, but if not, we're very proud of Vasco da Gama, so the name stays. And basically, what has been done in this ship was to install the system from Technoveritas. I'm not. It was already mentioned, so I'm not to take long to describe. But basically, is to go from heavy fuel to marine gas oil, and by using of the selective catalytic reactors, the ship is able to reach emission levels below Tier 3, which means that it can operate in Norwegian waters, so is as clean as it can get now before the electric and some of the systems that were mentioned before, like the BOEM, are also integrated to allow the company to monitor the systems. In terms of design, Vera Navic, which is involved on the electrical ferries as well, is working with several North European yards, and this is one of the projects where they've contributed by concept, basic design, and structural design, offering a full service. In terms of new projects and development and research projects, Technoveritas again has developed, and this is a project that was funded by Fundo Azul, and basically they've developed and built an unmanned surface vessel targeting the Portuguese Navy. And the vessel has a few interesting characteristics, such as an hydrofoil propulsion system that uses the energy of the waves as part of the propulsion of the unit. The unit has been built. This is a 3D drawing, but here is the hull being loaded or to appear. So it's going to be tested. Hopefully, it's going to be, and I cannot guarantee what I'm saying, but hopefully, it's going to be involved in some military exercises in the short future that the Navy, Portuguese Navy, is going to carry out, probably in the area of Troia. And it has the capability, just to give you an idea of the applications that they aim that they can do with this unit. Border and customs, and sorry, I have to read it because I didn't memorize it. Border and customs control, anti-submarine warfare, navigation monitoring of the economic area of Portugal, fisheries control, prevention and reduction of marine pollution. So it's prepared for a range of services. This is a prototype. It can be built to a larger scale. The hull was built by one of the yards that I mentioned before from the Algarve, Nautiber. Final note, main challenges. I should end with a positive note, but we have to complain about this every time we can, which is unfair competition, fierce competition for other countries, and this is an issue that has been addressed not just by Portuguese industry but also by shipbuilders around Europe. We have been trying with Sea Europe since 1998 to convince the European authorities to apply their own rules and their own decisions, and we've not been successful. Just to give you an idea, we don't have any protection because the ship is not imported to the boundaries of the EU. So if we built mobile phones, we could complain, but because we build ships and the others build ships and the ships are not physically coming into the borders of the European Union, we are left without any instruments to defend ourselves. This is also coming out from all the discussions we've had in social dialogue in Europe, aging of the workers and the lack of qualified workers for technical and more traditional technological professions. The impact of environmental regulations, which is not negative, is a positive, is an opportunity. The problem is that we don't know where we're going to. A couple of years ago, it was LNG. Now is synthetic methanol, probably hydrogen, maybe fuel cells, maybe batteries. So again, a lot of regulations. The time is becoming very, very short to apply and comply with the rules. And we don't know what solutions we can offer because we don't know what the owners want. Maersk, for example, is going for synthetic methanol. Others are going for LNG, as we've shown before. Technoveritas is promoting hydrogen, and in the meantime, even the harbor authorities cannot decide where to go and what to install to supply. But we're not giving up, and we have a lot of projects ongoing, and I can talk about two at least. There's a new dock being built in Viana do Castelo. All the preparation of the access in the harbor are done, and as usual in Portugal, we are waiting for West to approve and decide on whether or not the project can go ahead, and it's taking more time than expected. And other yards are going to upgrade the facilities. We expect that the overall amount in investment in the industry in the coming years is going to be above 300 million euros. So there will be a lot of efforts done to keep on working. As Technovaris has said, they are approving prototypes to develop new systems in hydrogen. There are projects going on between Portuguese ship owners and the shipyards to potentially install these equipments in a ship and make it a testing prototype. And that's it. I've been asked to give an overview of what the industry is doing. I hope I highlighted some.
Let's continue with the next talk by Maria Mineiro, the scope of EA grants in Portugal. Maria Mineiro belongs to the European Economic Area Financial Mechanism, the focal point. Thank you. Please.
Muito boa tarde a todas e a todos. Good afternoon to you all. Thank you very much, representative of the EA Grants Portugal. It is with great pleasure that EA Grants joined the conference about marine simulating training and sustainable shipping. First of all, I would like to greet the hosts of the event in the person of Professor Luís Filipe Batista, and also the previous speakers, in particular, the partners of the initiative, the Norwegian University of Science and Technology, and also the University of Southeastern Norway. I would also like to greet Conceição Santos, the Deputy Director General for Maritime Policy, and all the participants that are here today. So at EEA Grants Portugal, we are very pleased to have approved funding to support the marine training for seagoing courses, which will allow the acquisition of new and advanced simulators to reinforce the school capacity of training officers for the national and international merchant navy. And this acquisition also contributes to the supply of qualified professionals and for the cooperation with foreign nautical institutions, namely the Norwegian partners. And for those of you that are not yet familiar with the EEA grants, it is a financial mechanism that results from the agreement on the European Economic Area, which was signed in Oporto in 1992 between the member states of the European Union and 3 EFTA countries, Liechtenstein, Iceland, and Norway, in order to grant their participation in the European internal markets. And the parties to this agreement created this financial mechanism known by EEA grants, with the objective of reducing social and economic disparities between the donor countries and the beneficiary countries, and with the second objective of strengthening the bilateral relations between these countries, including Portugal, which is one of the beneficiary countries. And Portugal, in the EEA grants financial mechanism, has an allocation of 102.7 million euros, supporting 5 programs in 5 different areas, which are blue growth, environment, culture, work-life balance, civil society, and we also have a special fund to promote and strengthen the bilateral relationships between these countries, which is the Fund for Bilateral Relations. And the Blue Growth Program, the first one that I was telling you about, and which is the program that supports this predefined project on marine training for seagoing courses, has a special importance within the scope of EEA grants, not only because it has the most significant global financial allocation in the current funding period, which is 39 million euros, but mainly because it has a broad scope in 3 different areas. First of all, blue economy, with special focus on PMEs, or SMEs, sorry. Second area, the research and innovation. And the third area, the maritime education and vocational training. And in the Blue Growth Program, it was approved already 109 projects with a total allocation of 41.6 million euros. And this Blue Growth Program It is also the program where that has a natural, strong bilateral interest with the EEA grants donor countries, such as Norway and Iceland, due to the importance that the sea has in these countries. And in general terms, it is important to say that we are halfway through the implementation of the current mechanism that goes between 2014 and 2021, and that will close in 2025. I also suggest that you can consult the joint website of EEA Grants and our social network, where you can find more information about all the programs and all the projects supported, as well as the funding opportunities that are still available. And before finishing, just let me tell you that in May 2021, under the Portuguese presidency of the Council of the European Union, it was agreed the terms to initiate the negotiations with the 3 donor countries for the next funding period of EEA grants, which we hope can swiftly reach completion to continue this important support for Portugal. And now, finally, I would like to wish the greatest success for this project, which will be the new paradigm for the training courses for future merchant marine officers in Portugal, leading to a better performance, higher quality, and more cooperation between the partners involved from Portugal and Norway, and also with similar institutions. So thank you very much, and good luck with the project and with all the developments. Thank you.
So thanks for the presentation. We'll continue to the next talk, GEA Grants Blue Grant Program in support of research, innovation and training by Dr. Conceição Santos, Vice Director of the GPM, Director General of the Policy of the Sea. Thank you very much.
Good afternoon, everyone. First of all, I'd like to thank you for the invitation to be here today. It's always a pleasure to come here. My presentation is about the Blue Growth Innovation and SMEs financing program. Until now, you have been seeing different projects. Now I'm going to tell you about something that is common to all of them, that is the financial support. It is a program supported by EEA grants, as Maria said before, and I will present the main figures of this program and give you an idea of how this started. And since we are starting to think of the next period of financing, it is important to better understand, because what you can say to us and to identify the missing parts for financing is always relevant. So this program is mainly focused on the blue economy, where the maritime sector with the shipping chain value is very relevant. And the main part of the money is allocated to business development and innovations, namely SMEs. But it's a cost-cutting program where we are funding the research and innovation, but always in support of the economy, and the projects that come with the companies together are more granted in principle. Education and training is very relevant, is supporting all the blue economy. That's why we are supporting this project here in the nautical school with the better simulators to have better professionals in the blue economy. And of course, bilateral relationships is always relevant in all the projects. We had 10 calls. Now all of them are closed. The projects are undergoing. This is the main figures of this program. We have an available fund, 42 million euros, and now we have about 109 projects approved. But as you can see, we had a higher demand with more than double of this number. Now we have 68 projects with donor countries, and the total investment approved is 54.5 million euros. It's relevant for the blue economy, and it's relevant because it fulfills some doubts and some problems we have in Portugal in terms of financing, considering the European funds and also the Blue Fund that we also run in DGPM. Nowadays, the projects, some are starting, but others are running. Nowadays, 24% of the program is executed, and we expect by the end of this year to have more or less 1/3 of the program totally executed. Communication is very relevant for us, and projects are more, but communication. Oops. I don't know what happened. Okay. Not bizarre, but never mind. Here you have the geographic distribution, and it's very interesting to observe that, of course, Lisbon has the higher amount of the money. And this is relevant because the other funds, namely the European funds, are financing in other regions. And in Lisbon, we have a lack of financing in many projects. And here hands comes to fulfill this kind of problem. I don't know why. One of the predefined projects we have in this program is this marine training and seagoing courses here in the nautical school. And this is a predefined project because we have just one nautical school in Portugal. So it's not a competitive market, and it is a public school. That's why we are support a predefined project. The solution comes because we saw that this nautical school needs more updated instruments and simulators. And we negotiate with the donor countries this project. The idea is to enhance cooperation with foreign nautical institutions, exchange teaching experiences, sharing improvements with other academic programs, and give mobility to teachers and students to have a better international environment in this school. And of course, it's very relevant to strengthening bilateral relationships with, in this case, with Norway. And all of these things are considering in this project. So we expect this is just a way to improve the quality of this school and starting for better and deeper the cooperation in the future with Norway and other donor countries also. So this is the main things that I would like to bring here today. Thank you.
Thank you very much. Let's continue till the end of the conference. And now, next presentation, the evolution of port sector by by Claudio Lauro from Dgrem, Portuguese Maritime Administration. Thank you.
Hello, good afternoon. I'm here on behalf of my Director General, Mr. José Simão. I'm thanking the school for this invitation. I'm talking about the port evolution and the Portuguese maritime perspective. Our mission is mainly to be the maritime administration, the fisheries authority, and the maritime spatial planning and sustainability. We have regulation and control and surveying activities. Mainly, my presentation is not going. Is everything okay? So this is what I was talking about. We have many clients. We have to deliver services to all these international, European and national associations, economic agents, and we have to render our services to them. We have the sea platform, was well spoken before, to account for in terms of sustainability regulation. We have more than 100,000 vessels in our Portuguese flag, and we have more than 700 soulless vessels to account for. We have more than 50,000 seafarers, hopefully. Yes, we have. And we have more than 15,000 fisheries professionals that are also seafarer trained. We have 12 big complex port infrastructure facilities, and we have 4 rivers that can be navigated by commercial ships. Also, we have 63 port facilities certificated. We also set the standards and the licensing for all the platforms that are being set on the Portuguese Sea. We have also other activities like port state control, vessel traffic system, marine litter monitoring, and other licensing in other areas. Therefore, we had to change in the recent past because, as has been told here, some of our clients' perception was not the best. And we had all this opportunity in our flag for exponential growth. So we took our heads and we made a plan. We planned that we had technology, loads of apps. We had more than 170 services provided to our clients. We had 42 IT systems, we had equipments, and we had all these procedures that can be dematerialized into the business. But we had no process that was digitalized. And we had, as was said before as well, laws and regulations that were inadequate, and we had all these challenges coming and we had to change. So we set our attempts to make a strategy managing change towards digitalization, and we set our aims, our vision, our strategy, and the main key features of our service delivery. Our aim was necessarily to improve the response time. We wanted to concentrate the service delivery in one single point of contact, reduce context costs of service delivery, and promote a network collaborative work in shared service delivery in all areas of the Portuguese maritime administration, because we aim to be one of the first public service to deliver innovative e-services for citizens, other public services, agencies, and business across the world. So our strategy was aiming at regulatory simplification, engaging and accountability with people and technology, and re-engineering our processes. Oh, there is our strategy. Therefore, we improve our service delivery levels was to have simpler and more focused regulations, creating one point of contact, one process, one IT system. Actually, there are 3 big IT systems as per each one of the areas. We want to use and reuse our client info. We want to have data, to have statistical information in order to create more accurate reports and solutions in the future. We want compliant documents. We want online printing and secure documents for all our customers. Therefore, we had to have interoperable systems with electronic and physical secure certificates issuing and online certificates that were traceable in one customer service support. The results, there were many regulatory simplifications, namely SNAM, the creation of the Maritime Administration in one-stop shop, regulatory simplifications to the merchant fleet, the legislation about armed guards, the creation of the seafarers booklet for the new regime for seafarers, simplifications to the recreational craft regime, and the creation of the Portuguese single window was also initiated in the past 5 years. So this is the main strategy for our digitalization in maritime administration, where all the our stakeholders are involved, and we aim at producing e-services to them, namely in engaging schools that produce e-certificates for their seafarers and their yachtsmen that then go to the sea. We have our vessel traffic controlling all the seas and gathering information on security and safety. And we have all ships registered with electronic certificates. And this as well can provide information to ports and shipyards as well. And we can also report to the international organizations that we are accountable for. We also have the same model for fisheries, because fisheries always Dgrem is the authority for fisheries as well, and we have port reception as well for fishing markets and aquaculture licensed establishments, and we have also the need to report to EU organizations. In here we have all the systems where the inspections are made on real time in regards with our IT systems that survey all the fishery boats. But this was not possible if we had not issued electronic certificates, and we have also hard copy certificates for seafarers and persons. And the compliance of these documents are accomplished by a third party, and they are digitally signed, all the documents, and they are verifiable on our website, and they are authentic. The authenticity is guaranteed by a digital signature in our eDocs, and the hard copies have printing systems that guarantee that the IVO ink, the rainbow effect, and the holograms guarantee the authenticity of these documents. So you can try it if you can. This was an issued document for a seafarer, and actually you can test if it's still valid. Are you trying it? Yes? Okay. I'm waiting. This is a very slow computer, so.
This is very slow.
You don't have access to the document. You only can verify its validity. Press again, because probably it's just no, but it's valid. You should get one like this. Yeah, it never fails.
Blah, 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 blah.
Yeah. Is it okay? Is it still valid? I used an old QR code, so.
Yeah.
Yes? Okay. So this is mainly the documents that we are issuing at the Maritime Administration, because we aim to be the first in class in world digitalization. So we are issuing e-certificates for seafarer, for ship certificates, and for all the sea economy licensing activities, aquacultures, windmills, whatever everything is run on e-certificates. So, as we are the Maritime Administration, we also are part of JUL, Janela Única Logística, that is the national project for port logistics channel that is being implemented. And as I said before, the designing and implementing of end-to-end paperless is also a process where we mix people, procedures, and technology. And JUL is one of those projects as well that aims at intermodal transport, and papers are replaced for e-certificates and data exchange as well. So most of you already know this graphic where all the intermodal port and land transportations are met in one place. And some of you may know how it occurs. And I just brought some images of what JUL is nowadays, where you can find all port facilities available for our ships that are incoming. And to give you an overview what the potential of JUL has, and knowing all the information on ships and on services on ports, and that are available for, for all the Portuguese ports. So the future for us, for ports, for the Maritime Administration, it's to increase all our services, to develop more services. Shipping is a traditional market where people are very traditional. So developing systems for traditional people is an iterative process where we learn from them, we develop the systems, they learn with the systems, and we develop again. And this is a cycle where we are trying to do better, to improve the services, and to improve as well the security and mobility, because some services only can be improved in ports when we have more internet access for even the captains and the ships, and then we can design these mobile-friendly documents and accesses and apps for ship owners, for ship crews, and all the seamen's look and everything. So thank you for your attention. Thank you for this.
So finally, we are going to the last talk by Georgios Christofi, Virtual Reality Environment for Ship Inspection, and came from European Maritime Safety Agency. Thank you very much. This is the European Maritime Agency for finalizing our conference. It's the best situation that we can have. Thank you very much.
Good afternoon. Obviously, being the last one, I will try to be as brief as possible. Sardines are waiting, as said by a previous speaker. So my name is Georgios Christofi. I'm coming from Cyprus originally, and the European Maritime Safety Agency. EMSA is a decentralized EU agency based here in Lisbon. Our agency was established back in 2002, and our main mission at the time was to ensure high-level safety, security, and pollution prevention and supporting the EU maritime cluster. Obviously, throughout the years, much more has been added to our mandate. Now we support non-EU countries, those applying for accession to the EU, third countries that fall under the European neighborhood policy, like North African, Middle East, Black Sea, Caspian Sea countries. And in that respect, we have a budget of approximately 80 million per year. We employ 270 more or less members of our staff from all over Europe. And we are based in Caixo de Sodré here in Lisbon. Now, EMSA practically implements a strategy which can be somehow described what we call the 5S. So safety, security, simplification, sustainability, and surveillance. And these 5 S's have various activities, and they are in a horizontal manner interacting between them. I was very happy to hear earlier on some of the speakers mentioning SafeSeaNet is one of our simplification projects that supports the facilitation of ships in ports and maritime traffic. We have Earth observation systems that support pollution prevention and pollution response, drones for search and rescue, pollution response, supporting even EU NAV4 and piracy, anti-drug operations, and many other tools that in practice are developed and hosted by EMSA, but are used by the competent authorities all over Europe to report to target ships, to report inspections, to report accidents, and many other activities. However, today we decided, and considering that we were kindly invited by a Maritime Training Academy, to show practically how modern technology supports our training programs, how we use virtual reality to support and fill in a well-identified gap in our training programs. Now, as I said from the outset, our agency was supporting training. And since 2020, we have established what we call the EMSA Academy, where we practically move into a more professional way of building up the capacity of the various competent authorities in the member states and beyond the EU. And basically, our aim is to provide learning services outside formal education. In simple terms, basically, we are developing curriculum, we are developing syllabi, and we offer learning services to support specific job profiles within the overall maritime domain, whether are port state control inspector, flag state inspector, accident investigation, search and rescue personnel, pollution response personnel, VTS operators, and many other activities. Our beneficiary organizations, as I said, they come from EU member state, EEA, including Norway. The European neighborhood policy countries, we implement SafeNet and Black Caspian Sea projects. The potential future EU member states. Paris MOU members, which incorporates EU and non-EU, like United Kingdom, Canada, Iceland, Norway, and other agencies like Frontex and the Fisheries Agency, which is very close to what we call the tripartite working arrangement for coast guard operations. Now, an introduction to our EMSA Academy. We implement the relevant quality management system for providing learning services outside formal education. We apply modern pedagogical approaches in developing our learning activities, our syllabi, our curriculum. We use blended training, which means that we apply online and presential trainings, online both in synchronous and asynchronous modes, and presential by bringing the relevant people here in our premises, or by sending our experts to physically deliver trainings or parts of the trainings to the member states and other beneficiaries. One of the main elements that was identified by our customers, our beneficiaries, is that they really wanted to have more field training. As I said earlier, we are training inspectors in many ways. We are training search and rescue personnel, pollution response personnel. So people were actively asking for field training. You understand that for an agency, it's rather difficult to have its own ship, training ship, or even to have facilities that will facilitate all these kind of field trainings. That is why we invested into modern technology. That is why we invested into virtual reality, which is, again, a costly project, but in a way, it's a more cost-effective comparing purchasing our training ship or creating our own MRCC center, training center for search and rescue operation and pollution response. Therefore, what we call VRESI, the virtual reality environment for ship inspection, was created. We started this project in 2019. It's an ongoing project. It has been enhanced many times, more and more as our learners immerse themselves into VRESI, more and more we have more requests and more areas to invest into. Our virtual reality is, it takes patience
to look at the screen.
Okay, our virtual reality it's practically a very realistic environment, very immersive, and obviously configurable. In other words, we have created prototypes, we have created a number of ships, number of ship types, but it's configurable. We can use it for training purposes, but we can also use it as an assessment technique. So we can create what we call treasure hunting. We can put hidden deficiencies, for example, for the inspectors, and if they manage to perform the inspection and identify those deficiencies, they go through to kind of the next level. Obviously, it's a safe and controlled environment. It's a virtual environment with all the limitations of a virtual environment and the impacts that this can create for continuous use. The participants can connect through the internet, so it's available through our e-learning platform as well, but it is also offered through our virtual reality goggles. We have a virtual reality environment in our agency with a 360 screen, and it's also available on the computer for the participants of our learning programs. It's a system, and like all systems, has an underlying architecture beneath. So there is a server which supports the entire process, and this server has been developed very closely with the contractor, but it's hosted in our ICT environment. The client can use the tool, as I said, through his or her browser using the internet, can connect through our own dedicated e-learning platform and follow either standalone scenarios or learning activities that have been developed within the context of a given course. It can be used also, as I said, with our goggles, and we brought with us, but probably it's too late for a demonstration. Whoever is interested, we can have a quick demonstration. It is very much depends also on repository. So we have scenarios already pre-defined into the system. So you can actually decide whether you want to visit the bridge and verify the documents that are to be kept on board. If you want to visit the engine room, if you want to visit the cargo hold, the ballast water tank, it depends on the scenario, and all this obviously has to be pre-defined, and there is a repository. And as I said, it is available through our learning management system, which is what most of university schools use nowadays. Now, why we have developed this, as I said, to fill in a well-identified gap. However, it wouldn't be of an added value if the RESI was not linked with the intended learning outcomes. In other words, if the learning activities offered through RESI were not linked to what the learners are expected to learn from the course. Here I gave some examples. For example, in the flag state curriculum that we have for flag state inspectors, we use RESI to help participants if they are new entrants or experienced learners in certain assessment activities to describe or learn ship design, construction, the various features of the ship, navigation, and engine operation system. We simulate inspections either for flag state or post state or for environmental, like sulfur inspector. We use it to train people how to collect the relevant ship documentation, for example, in the sulfur inspector's common curriculum, how to do fuel sampling, where to find the proper points for fuel sampling on board the ship in accordance with the appropriate legislation, and of course for post-take control inspector, how to demonstrate that they comply or they have adhered to the knowledge that they need in order to implement the relevant instructions of the Paris MOU and of course IMO legislation. We have chosen certain samples, snapshots from our environment with pictures. As I said, we have developed certain prototypes of specific ship types because obviously the training environment is different on the basis of the ship type. The requirements are different for an inspection, and we really need to give the opportunity to the inspectors and other safety or security related personnel to attend and be able to recognize, first of all, the ship type, and also to know how to inspect and how to move around various ship types. We have also designed and used various ship compartments. Here you see a snapshot of an engine room, another snapshot of an engine room. And by walking around these compartments, there are identified spots where the learner would get information on the type of the equipment, how to inspect this equipment. There are cases where there are pop-up videos where the learners would actually visualize how a proper inspection should be done. For example, if a learner is on deck and reaches a lifeboat, there will be a live video demonstration of how to inspect a lifeboat, how to perform an evacuation drill, how to inspect a free-fall lifeboat, all types of these things. Similarly, on the bridge, there are all the bridge equipment, all the relevant documentation. And the tool is also interactive, so we have created simple interaction between the avatar of the inspector and the crew in order to ask for the certificates, get the certificates, make some comments, and then produce a report. Therefore, the tool is also linked with the various tools that the inspectors will use in real life, like that is on the route check. So the virtual reality, this is also a CO2 room, so where depending if you have a new entrant, they will be acquainted with the requirements of the CO2 room. If it's an experienced inspector, will be required to inspect them. Now, the virtual reality is very much in use as we speak today from these specific job profiles, so mainly ship inspectors. But in the years to come, we are investing to enhance the tool to be used for accident investigators, for pollution response, and the interaction between an accident investigation and how to react to pollution response incidents and probably to search and rescue. The tool for anyone who would like to visit or to make a formal visit to EMSA would be available, of course, in our e-lab. But as I said, if we have time, we can actually demonstrate it on the browser, or you can use the Google. But I see already that it's 6 o'clock. So I was very quick and I was very brief, but if you have any questions, I would be more than happy to reflect. Thank you.
So finally, we conclude the conference. Thank you for your presence. I'm sure that it was a very interesting and productive conference. So we have possibilities to cooperate and improve activities and share opinions and contacts with the organizations that have been presented here, those projects. For finalizing the conference, I will ask the speakers to come here to take a photo, and we have a small gift to you in order to thank you for your presence here for this conference. Thank you very much. Please come to here to take a photo because it's very